A lot of things can affect your health, your diet, your lifestyle, that weird mole, and your genes, of course, your genes. And some of your genes come from a Neanderthal. Typically, what percentage of genes does someone have from a Neanderthal, and where did we get them from? A Neanderthal, I guess. I guess with the birds and the bees, I can imagine how we got them.
On average, you would say that maybe 2% of your genome comes from Neanderthals.
For some populations, it's a little bit less. Africans have less Neanderthal DNA. For some populations, it's a little bit more. They have Neanderthal DNA and Denisovan DNA, like East Asians, Papuans, Native Americans. So how do these genes affect your health? That's the question geneticist Laurits Skov is working on. We had a big chat about it, super interesting, and we even got to check my genome for some Neanderthal traits. Let's just say I knew it. Okay, I knew it. Everyone said it. I'm well known for that. This doesn't surprise me one bit. This video is sponsored by Ground News. We live in a world where it's hard to feel like you've got the complete picture, and equally easy to fall down a crazy rabbit hole. God knows I do. This is where Ground News comes in. It's the world's first news comparison website. You can see who's reporting on different stories, how they frame the stories, who owns the media company, what is their reputation for factual accuracy, all these things. Let me show you how it works. Check out this story on United Auto Workers successfully negotiating a better contract. Shout out to them. On Ground News, I can see more than 90 articles have been published on this, and coverage is mainly coming from left and center. If I scroll down, I can see every article on the topic and compare all the different headlines. OPB, Oregon Public Broadcasting, leading with the fact that workers secured a pay rise. Fox Business, not leading with that angle, surprising absolutely no one. It really does help you get out of the rhythm of news and stuff that's algorithmically selected for you. If all of that sounds good to you, head to ground.news/Stefan to get the Vantage subscription, which is what I have, 40% off. It's a bargain. Back to Neanderthal DNA. Cass, how many genes do we have? And does every person have the same amount of genes?
More or less, yes. So the number of genes, we actually don't have an exact number because people have different numbers, and we haven't found all genes yet. So the current estimate, it's something like 20,000 genes.
20,000 genes.
And all these genes, like sometimes some people have versions of genes that don't work anymore. Sometimes genes get duplicated, so there becomes more of them. And it's very complicated figuring out what a gene does, because many times what happens is that genes sort of work together. Lots of genes work together to affect something. Your height, for instance, how tall you are, is believed to be affected by something like 12,000 genes.
Oh, wow.
All pushing and pulling, making you a little taller, making you a little shorter. And it's a combined effect of all these that then determines your height.
You might think, 20,000 genes, not so bad, not so much to study. But each gene is made up of base pairs. A base pair is what geneticists give those 4 numbers to. A, C, G, and T, I think. Yes. They make up the rungs on that double helix structure of DNA. And you get one from your mom, one from your dad, of course. Your genome has 3 billion, with a B, billion base pairs. 3 billion positions on the genome, basically. That's a lot. That's a big number. I can't even begin to imagine how complicated it is to work out how all these things affect your health. And then on top of that, you could be lazy like I am, eating too many chalky croissants. Penny chalk. Plus lifestyle as well, I imagine. Diet, nutrition.
A very good point. Yeah, so there's a genetic component, and then there's a environmental component. And those are not always easy to disentangle from each other.
Considering how many genes we have and how many base pairs we have, and the fact that I smoked 20 cigarettes a day for like 8 years, I really wanted to ask Laurits, how can geneticists even possibly untangle how these things affect our health?
Let's pick the first one. There will be chromosome number 1 and position 69,869. And you have 2 T's here. So people could also have another base pair here. People could have an A or a T, or a G or a T, or 2 G's or something. So what if you wanted to test what effect does this particular variant, we call it, have on, let's say, height? You would gather all the people you have in your database, and you would say, what's the average height of a person having TT? What's the average height of someone having a CT? What's the average height of someone having a CC? And you would say, you would ask the question, does the TT combination make you taller than others or shorter? Is there any difference? And you would do this test for all, I don't know how many steps you have there, like how many positions, like maybe you have 1 million in total.
So I imagine then, when you're doing like a medical study like this, you need a big sample to be able to tease out just random variation, I suppose.
Exactly. That's a really good point, because there is so much random variation. And you're testing, we're testing 1 million things. Like, just by chance, some will look like they have a difference, even though they actually don't. Some databases are, they have in the millions of people, millions of genomes. And that's how you can find all these very small effects.
You must have a big computer.
We have big computers.
Yeah.
Otherwise, it would take forever.
It's probably impossible without them to analyze that much information.
You need like terabytes of storage, and you need to run the computer programs. You need thousands of computers running in parallel to analyze all these things. Yes. Wow,
that's a big operation. So, with 1 million samples and 1,000 computers, geneticists can start to put together the pieces of this genetic puzzle. All right, let's look at some Neanderthal genes. Should we start with EPAS1 first?
EPAS1. Oh yes,
EPAS1.
That's one of my favorite ones. That's a really cool one.
What's EPAS1? What's going on? Who did we get it from? And what does it do?
Yeah, so actually EPAS1 doesn't come from Neanderthals. It comes from the Denisovans, who we think lived in East Asia somewhere. And what this gene does is that it allows you to adapt to a life in high altitudes. So this gene is very common in people who live in Tibet today, and it's not so common in the rest of the world. Like, the oxygen level is lower. You need that oxygen to produce energy and to survive. So your body's like, okay, let me make some more red blood cells, because those are the ones carrying oxygen around in your body. And then your body starts doing that. That's like a way to adapt to that. The problem is that the more red blood cells you put into your blood, the thicker it becomes. And that puts a lot of strain on your heart. And like, if you do anything that takes a lot of energy, for instance, giving birth, that can be very dangerous.
The Denisovan variant of this gene has survived in present-day populations, present-day Tibetan populations. Clearly, this is a great example of a gene being strongly selected for. Modern humans moved into that environment, made beautiful and romantic love to a Denisovan, and the children who inherited that EPAS1 gene just became better at surviving in that environment, had more kids, lived longer, and so now it's widespread amongst Tibetan people. Believe it or not, viewers, I am not from Tibet. And that is a surprise to some of you. Can I search for EPAS1? Do you think it would say it?
Nope.
No?
So every position has a name. You can see these RS numbers to the left.
Yeah.
I think a strategy could be to figure out what are the RS numbers in EPAS1 called and search for those. But
that might take a while, huh? Would it typically be in the supplemental information, do you think?
Supplemental, yeah. Yeah. It's just, look, here is this chromosome position.
Yeah.
You would search for either one of those positions if you wanted to.
So I can search for this position?
You could, yeah. If it's, because 23andMe, they don't check your entire genome. You only check some positions.
Yeah, that's true.
And they might have checked that one. They might not have.
Here we go.
Hey, they did check that one. Amazing. Okay, and you have AA. Can you go back to the thing? So A is the most common one.
Yeah.
That's the one we have. And the one in Denisova, you can see the Freck Denisova, they always have the alternative one. This is the frequency of the alternative one, is the numbers. So a Denisova will have a G, and you have an A. So you probably don't have it.
So the Denisova will have a G, and I have an A.
And you have two A's.
And I have two A's. So surprising absolutely no one, I do not have the Denisovan high altitude adaptation. As a European, the paper says I only have like a 0.001% chance of inheriting it. But for Tibetans, of course, is much higher. Okay.
But you can see, if you look at the different frequencies, look at the frequency in Tibet. You can see here, it's like 81%.
Wow, that's so high.
Yeah.
The vast majority of Tibetans have that genome.
Exactly.
So this is a question for you. Does absolutely everyone have an EPAS1 gene?
Yeah.
Okay.
It's just, do you have the Denisova version, or do you have the... Like, it's weird to call it human because humans also have this version. Like, but let's say the one that originated with anatomically modern humans.
We've already mentioned how your health is a combination of your genes and your lifestyle, your environment, and a little bit of luck too, let's be honest. Not good for your health getting hit by a bus. Laurits had an absolutely textbook example of a Neanderthal gene that really clearly shows this tension between lifestyle, environment, and genetics. Nature versus nurture, you could say, perhaps. There was a gene, a Neanderthal gene, that affected whether our susceptibility to COVID. Is that right?
That's true. There's actually been evidence of two different Neanderthal genes having different effects. So one that increases your risk of being hospitalized, at least this study came out in 2020, so before vaccines.
Mm-hmm.
But then there's a Neanderthal version of a gene that if you have that, your chance of being hospitalized for COVID is 50%, like 50% higher than if you didn't have that gene.
Wow.
Oh wait, it was actually a 60% increase, sorry. So what I'm showing you here is, so this was data from early in the pandemic, and this is your risk of being hospitalized based on different ethnicities. So you have, this is from the States. If you're Black, if you're Hispanic, if you are American Indian or Alaska Native, Asian, and then white. And a lot of genetic studies is done in these giant databases, and most of the individuals in those databases are European. So actually, to be fair, we mainly know about the effects of genes in Europeans and not in other populations. Most of the time they're similar, but sometimes they're not. This is an example of, if you have a Neanderthal version of this gene, your risk increases by 60%. So, and the baseline is if you were white in the States. So you can see it's higher, but it's still nowhere near as high as if you are Black, for instance, or if you're Hispanic. And that version, that Neanderthal allele, is very rare in those populations. So it's not because of that. It's because of other things. It's because of the environment. This particular case, because of systemic racism. And so this is an example of, yes, this gene increases your risk of being hospitalized for COVID, but there's a lot of other factors that are environmental, that are not about your genes, that also determines your risk of being hospitalized.
In the sample of the genome that I had, I didn't have my full genome available, every position on my genome available. So it turns out we couldn't test if I had this Neanderthal COVID gene that was going to wind me up in hospital. But it is interesting, isn't it? Even with a genetic risk that increased your chances of hospitalization by 60%, that still isn't as bad as just being born in a poor or disadvantaged community. Pretty sad indictment of modern healthcare, to be honest, modern society.
So this just goes to show that it's never the whole story, just environment or just genetics. It's always some interplay between these things.
obviously not a great genetic legacy from Neanderthals that you would have a 60% increase chance of hospitalization from COVID-19. Not great. But there are actually Neanderthal genes that reduced your risk of going to hospital, that improved your chances of fighting off COVID-19. As Laurits would go on to explain, though, it's no coincidence that Neanderthal genes did affect our response to COVID-19, really, because so many Neanderthal genes are involved in our immune system.
This is one of those many genes affect things. And even if the Neanderthal variant increases your risk, there could be another one that decreases your risk.
Yeah.
And this is of course because COVID wasn't around 40,000 years ago. Not the way we know it now today, at least. When humans and Neanderthals met. So these versions of genes, they were meant to do other things. They were probably selected for fighting other viruses back in the day or other types of pathogens.
Okay, so you think these genes that we got from a Neanderthal that affect COVID also had a role in their immune system, most likely?
Yes. So if you look at all the different genes we got from Neanderthals and which one have the biggest effects, most of them are immune genes, actually.
Oh, really?
We don't know why that is, but the most agreed upon, let's say, explanation is that when modern humans left Africa, they encountered new environments. And that means new pathogens and new viruses. And those are things that can kill people. Mm-hmm. So supposedly Neanderthals and Denisovans were already living in these environments, have some built up immunity, some genes that help them with the local viruses and local bacteria. So when modern humans meet them, it's very good idea to get the Neanderthal or Denisovan version of some immune genes, because that increases your risk of or your chance of survival.
Interesting. But what's interesting is you say it's a very good idea, but of course we have no choice over this.
Nope.
This is just natural selection.
Yes.
I suppose
so here,
over thousands of years.
Yeah.
It makes sense that when our ancestors, boinked a Neanderthal, their children got these new genes, that evolution would kind of favor keeping a few of them that affected our immune system. It's probably good to have as robust an immune system as possible. Laurits would go on to explain, though, something that absolutely blew my mind, genuinely. I'd never heard of this before, that there are entire regions of our genome where there is absolutely no Neanderthal genes that we're aware of. Geneticists call these Neanderthal deserts. So does that mean the genes we purged, a lot of them did affect the survivorship of humans deep in prehistory?
That seems to be the case. So there are some evidence of places in the genome where no one has any Neanderthal DNA. These are called Neanderthal deserts. There's like quite large regions where no person alive today has Neanderthal DNA. And when we look at that, those ancient humans that I talked about, none of them have any Neanderthal DNA here either. So supposedly here there was some thing where a Neanderthal gene does not work in the human context. It's not as simple as what I'm about to say. So just keep that in mind.
Caveat. It's more complicated than this.
Yeah, spoilers. That's not always the case.
Yeah.
So there is a region, a very large region, something like 10 million base pairs in length, where there's no Neanderthal DNA in modern humans. And in this region, there's also a gene called FOXP2. And this gene has something to do with speech. So there's remember, like, mutations happen all the time. Mm-hmm. So there is a family in the UK, I think, actually, where their version of this gene doesn't work. Mm-hmm. And what that manifests in is that they are cognitive completely normal. They can understand words, but they have this struggle to form sentences.
Interesting.
And some people were saying, is that a thing that distinguishes humans from Neanderthals, that we could do that? It turns out that Neanderthals actually have a very similar version of the gene to modern humans. So it looks like they have the same version, so they might have been able to do that too. Yeah. So that's one of those where at first it looked like, there's no Neanderthal here, it must be a human-specific thing. Then it turned out that Neanderthals have that version of the gene too. So it's one of those. So what's really going on here?
The FOXP2 gene is an interesting one, isn't it? Me, personally, I'm of the opinion that Neanderthals had to have had language in some way. Language is so crucial to what it means to be human. I think it's easier to explain all the boinking we did if there was a little bit of chatting going backwards and forwards. Obviously, it's not strictly necessary. You can just give someone a seductive glance, but chatting helps, doesn't it? But the flip side of that is, why is this region that is very central to our brain development entirely devoid of Neanderthal genes? There are other Neanderthal deserts in our genome too. Another big one is around our X chromosome. What's interesting about our X chromosome is that it's responsible for your balls. It's your balls genes. They do a big job with your testes. There's a lot of divergence in the X chromosome. I am of the opinion that modern humans and Neanderthals here, we're the same species. We successfully mated, so it's hard to think of us as different species. But were we on the very edge of speciation? The very edge of it? Was there certain combinations of modern human and Neanderthal genetics that just weren't great at reproducing? It's possible. It's possible. It's possible. I don't think anyone can answer that question at the minute, but there was some incompatibility with the balls genes. I just love saying that. But it's true. Okay, bottom of the episode here. Bottom of the episode. Let's go out with a bang. Finish with a good one. Let's talk about Neanderthal prostate genes and how you should want them. Basically, it seems that certain Neanderthal genes reduce your risk of prostate cancer.
Maybe this gets too sciencey, but it decreases your risk by 0.2 standard deviations, if that helps you.
0.2 standard deviations. I can't visualize that. Is that a lot?
Not huge. Like this COVID thing definitely increases it with, more than a standard deviation, quite a lot.
Yeah.
This is like a much smaller thing.
Okay.
But you have it?
I do.
You do, and you have a C and a T, so you will have one of each.
One of each.
So you do have the one that reduces your risk a little bit.
Stefan Milo, top-notch prostate. Everyone said it. I'm well known for that. This doesn't surprise me one bit.
It's no guarantee that, it won't happen. Like, it happens to most men. It's just, it reduces your risk of when it would maybe happen.
No. Me...
No, you are immune now.
Me and my beautiful Neanderthal prostate are absolutely immune. Stefan Milo, Neanderthal prostate. Love it.
Yeah, come at me, prostate.
Come at me, yeah. Take that, haters.